Welcome back, Phi-Sci family. We're going to be talking about ionic and covalent bonding today, which will eventually relate much more to balancing equations and the conservation of mass and matter. So buckle in, here we go. A molecule is a term that we use loosely in chemistry when we don't quite understand what's going on, but there is a specific type of bond that we're dealing with when we talk about molecules. And that bond is the covalent bond, which we'll talk about in the next slide how that happens. But covalent bonds happen between two or more nonmetals, so that's the key part. If you have anything dealing with metals, important, you can't really call it a molecule anymore. Now, a molecular formula is just showing you how many atoms of each element there are. So this very first example is oxygen. Since there's the subscript of 2, the 2 says that there's 2 oxygens in that specific molecule. If you look at this, which I believe is sugar or sucrose, you have 12 carbons because of the subscript 12, 22 hydrogens because of the subscript 22, and 11 oxygens. So the little number is always to the right of the element it's describing. That's important to know. So what specifically is a covalent bond? It's all about sharing. Nonmetals are willing to share their electron pairs in order to make everybody a little more stable. And that's exactly the reason why it happens. They end up getting a full octet, or their outermost electron energy level is more full because they're sharing between them. Now, physical properties that are common in covalent bonds are that these guys tend to be gases or liquids, or basically that it's pretty easy to melt these guys if they are indeed solid. So their forces of attraction are pretty weak compared to what we're going to talk about soon, which is ionic compounds that involve metals, not just nonmetals. Since covalent bonds are sharing, there's 3 types of bonds. You can either be a single bond, which means one pair of electrons is being shared between them, and that's an example right there. You can have a double bond, and a double bond means that 2 pairs of electrons are being shared between atoms. In this case, in an oxygen, which we breathe in every day, it has a natural double bond, or 4 electrons are shared between those 2 oxygen. And last but not least is the triple bond. Nitrogen has a natural triple bond between them, and that is meaning that 6 electrons or 3 pairs are shared. Remember, they're sharing and working together in order to get full, stable valence electron outer shells. And because of that, they lower their energy and they become more stable. So it's more favorable to bond than to not bond. Now, ionics are a bit different. Covalents, we're dealing with only nonmetals, but ionics, you need metals in there because it's all about negative and positive charges attracting each other. In order to get an ion with a positive or negative charge, you have to have the number of protons and electrons not be equal. If you have more protons than electrons, like 3 protons and only 2 negative charged electrons, they'll cancel out, but there'll still be 1 positive charge left. So that object or atom would have a +1 charge. Talking about charges, if you end up having a positive charge, you're considered a cation. That's the term, cation. And metals are the things that form cations. So think of a nice little kitty cat. That's a positive thing, if you like cats anyways, and they're called cations. As far as a negative charged ion, they're called anions. And those are nonmetals because they usually gain electrons and get a negative charge, meaning they end up with extra negative charged electrons. Now think of it as evil or bad or that anti-anion. Maybe that'll help you remember that it's negative. If you ever need to find the charge of an atom, just take the number of protons and subtract the number of electrons, and that should give you your overall ionic charge. Now, because of these charges, they're attracted to each other. The positive cations are attracted to the negative anions, basically meaning the metals and nonmetals attract each other. They're almost donating electrons, metals to the nonmetals, and because of that donation, you get that positive and negative charge, and they want to be around each other. They end up becoming neutral meaning absolutely no charge when they come together. And that's one of the main reasons they do actually form an ionic bond. They become much more stable when they are that zero charge. Ionic compounds do have their own specific set of properties, including a very high melting point. They're pretty darn stable. If you look at this crystalline structure of just table salt, the positive and negatives surround each other in like a crystalline structure, and they really do become quite strong. They are rigid and brittle, though, quite often. That's why if you rub table salt between your fingers, it's gritty and they kind of break apart. Not a problem. And then if you dump them in water and stir, a lot of them will dissolve. And if they do, as you can see in this picture, they break up in their positive and negative ions, or cations and anions. And when they do that, they allow something like water to now conduct electricity. And because of that, we call them electrolytes. You often think of Gatorade with electrolytes, but the reason you do is they force that in marketing. It's not only Gatorade that has electrolytes, it's just a fancy way to say they have salts in there. So if you get dehydrated after playing sports all day, you're replenishing your body and muscles of the salts you need for regular muscular function. A lot of this has to do, again, both covalent and ionic, with the octet rule. Atoms are constantly trying to be more stable, and to be more stable, they're willing to gain, lose, or share electrons in order to get that full set of valence electrons. The only exception, hydrogen and helium, they're happy with 2 electrons. Otherwise, everyone else is looking for 8 for the most part. This finishes up our lecture on the beginning stages of bonding. We talked about ionic and covalent bonding. Covalents are just dealing with nonmetals, where ionics are dealing with metals and nonmetals, meaning that the positive and negative charge, or another way to say it, the cations and anions, are attracted to each other. Thanks for listening, and good luck with the next series when we go into balancing.